Space is massive and full of secrets. We've found amazing things like black holes that even trap light. But what if there's something even weirder out there? Something called a gravastar. Imagine a dying star, much bigger than our sun, falling in on itself. Most scientists think this makes a black hole, a place where gravity is so strong nothing can escape. But some think something else happens. Instead of a black hole, the collapsing star could become a gravastar. This strange object would be super dense, with gravity so strong it bends space and time. But unlike a black hole, a gravastar wouldn't have a point of no return. Gravastars are still just an idea, but they're a cool alternative to black holes. If they're real, they could change how we understand the universe's most extreme places. Stars are born from clouds of gas and dust, pulled together by gravity. Over millions of years, the center of a star becomes like a giant nuclear power plant, turning hydrogen into helium and making energy. This energy stops the star from collapsing and keeps it shining. But for huge stars, this can't go on forever. Eventually, the star runs out of fuel and can't hold itself up anymore. Gravity wins and the star's center starts to fall in. In this extreme situation, matter is squashed to unbelievable densities. If the star is big enough, this collapse could make a black hole. But some physicists think something else might happen. Instead of becoming a tiny point, the star's core could change into a completely new type of matter. This weird material, maybe a type of dark energy, would stop the collapse and form the heart of a gravastar. Imagine a gravastar like an onion in space, with layers that are all different. Right in the middle is the core, a super dense area of dark energy which is still a mystery. Around the core is a thin shell of super dense matter, squeezed incredibly tight. This shell is probably very smooth and even, like a perfect ball. This shell gives the gravastar its name, acting like a special gravitational container. Outside the shell is the outer layer, a region where space and time are bent, much like around a black hole. Here, gravity is so strong that even light struggles to get away. However, unlike a black hole, the bent space and time of a gravastar wouldn't have a point of no return at its center. Section 4. Gravastars versus black holes. A tale of two titans. Gravastars and black holes are both amazing things that challenge what we know about gravity. Both are incredibly dense and warp space-time, creating areas of strong gravity. But they're also different. Black holes have an event horizon, a point of no return. Nothing, not even light, can escape. This is because the center of a black hole is thought to be infinitely dense, where physics breaks down. Gravastars, however, don't have this point of infinite density. Instead, they have a core of exotic matter that stops the collapse. This means gravastars don't have an event horizon in the same way. While the gravity around a gravastar would be very strong, it wouldn't be infinite. This difference is important because it means gravastars might let information escape, unlike black holes. This changes how we think about information and black holes.